Leibniz method of differentiating determinant makes this super obvious. Okay, this is basically the fact that the cross product, if let's say we have a cross product of two vectors, right? And then we have to differentiate them with respect to t, let's say. This is actually equals to derivative of u vector, right? Cross product with b plus u vector cross product with derivative of b. This is just like the product rule. The product rule is actually true even for the cross product, and that's actually pretty interesting. And not just for cross product, it's actually true also for dot product. You can actually prove for dot product pretty easily, right? But for cross product, like it might not really seem that obvious, right? But with this tool, a Leibniz method of finding determinant, it actually becomes pretty obvious. So that's what will be the goal of my video today. Yeah. So both are true. Okay, so now since cross product is defined on these vectors u and b, so definitely I will be assuming that this u vector, t vector, b vector, u vector, b vector are of dimension 3, right? I have to assume that dimension 3. And so their components will basically be this u1 of t. Now u1, u2, u3 are just scalar functions, right? And I guess you guys know how to differentiate them. That's pretty easy. And so now like this u vector prime will just be defined as this vector u1 prime of t, u2 prime of t, u3 prime of t, right? You just differentiate each component. Yeah. Similarly, b vector of t is just b1 of t, b2 of t, b3 of t, and then this b vector prime of t is the derivative of each component, right? Yeah. Okay, now with this all these things in hand, now let's go on proving. Also, but before we go into proof, let me state what this Leibniz method of differentiating determinant is, right? Okay, it says that, so let's say if I want to differentiate this determinant, let's say this is a1 of x, a2 of x, a3 of x, b1 of x, b2 of x, b3 of x, c1 of x, c2 of x, c3 of x, right? With respect to, let's say, x, let's give prime. So what Leibniz method says is, I just have to differentiate row by row. So first of all, okay, sorry, I forgot to give the sign of determinant over here instead of I'm giving matrix. Because for matrix, it's just element by element wise like derivative, right? If I have to differentiate matrix, I will just differentiate all the element at once. But for determinant, it's something like this. Okay, first of all, determinant of a1 prime of x, a2 prime of x, a3 prime of x, and then b1 of x, b2 of x, b3 of x, and then c1 of x, c2 of x, c3 of x. Added with now a1 of x, a2 of x, a3 of x with b1 prime of x, b2 prime of x, b3 prime of x, and then c1 of x, c2 of x, c3 of x. Again, this also added with a1 of x, a2 of x, a3 of x, b1 of x, b2 of x, b3 of x, and then c1 prime of x, c2 prime of x, c3 prime of x, right? This is Leibniz method. Now, if you guys know this thing, okay, now let's try to prove the thing. Now it will be very easy. Now we just want to prove that this derivative of the okay, this cross product is a determinant, right? Determinant of I is a k. Now u vector is u1 of t, u2 of t, u3 of t, another is b1 of t, b2 of t, b3 of t, right? So first of all, we will just have the derivative of first row, and first row is just constant, so it's gonna be 0, 0, 0, right? Doesn't matter what other things are, derivative will just be 0, right? Because a whole row is 0. Now the next thing will be I is a k, u1 prime of t, u2 prime of t. Let me write u1 prime of t again. u1 prime of t, u2 prime of t, u3 prime of t, b1 of t, b2 of t, b3 of t, right? Determinant. Plus now let's differentiate third row, right? And then this becomes u1 of t, u2 of t, u3 of t with b1 prime of t, b2 prime of t, b3 prime of t, right? Okay, so now I can easily see that this is 0 plus, now the second determinant is just the cross product of u1 prime vector with b1 vector, right? That's so obvious because the second row is all full of like the components of u1 prime vector, right, as you saw earlier, and the third row is just components of b vector. And plus, now the next thing is just now over here u1 vector cross b1 vector prime, right? So yeah, so like the fact that our derivative, this derivative of u vector cross b vector prime could be easily shown as u1 vector prime into cross b1 vector plus u1 vector cross b1 vector prime. Is this is actually so obvious from the fact from the like Leibniz formula of differentiating determinant, and then that makes it so beautiful, like that makes this technique so beautiful that this can literally give some like beautiful insights, like if anything, if it has to be done row by row, that can have a simpler form, something like that. But yeah, like a few weeks back I wasn't really able to prove this formula, and I was going through this again, and then now that I had this tool in my hand, like I was able to prove it so easily, and then I was surprised. Oh, so having some perfect tools is actually pretty helpful in math, something like that. So I felt that, and then I also wanted to share this with you. If you guys like were still trying to prove this like in a really difficult manner using algebra, so now here's a pretty good proof that is actually pretty intuitive and interesting. So hope you guys enjoyed the video. Thanks for watching, and do subscribe for similar contents, and I look forward to seeing you in the upcoming videos too.